So this learning packet is using trig identities to be able to find trig values. So we already talked about quotient and reciprocal. Quotient means dividing. So sine divided by cosine or cosine divided by sine. That's why they're called quotient. The reciprocal ones we've known since the very beginning. And then the Pythagorean ones are on the next page. So let's see what we would do to solve this. So, number one, it says secant theta equals negative root 30 over 3. And what are you asked to find? And then you have to think, how would an identity help me solve this to find the value of it? Well, secant and cosine are reciprocals. So which identity would you use? How would you know right away what cosine theta equals? You would just do the reciprocal and you have your answer. Now, I'm going to rationalize this so that you have negative 3 root 30 over 30. And then one more step, 3 goes into 30 10 times. So when you know an identity, it's to make it easier, not more complicated. Look at number 2. What identity will we use to make this simple? You're given tangent, cosine. What are you asked to find? Is there an identity that uses all 3 that I could use to find a trig value? And which one is that? That's called the quotient identity. What's the quotient identity? The quotient identity is tangent is equal to sine over cosine. What number will I put in for tangent? Root 2 over 4. I'm looking for sine. What number will I put in for cosine? Negative 2 root 2 over 3. And then all I need to do is get sine x by itself. So what do I do? What's the inverse of dividing? Now, we're not doing the reciprocal even though you see a fraction, because the reciprocal won't undo it. I just need to multiply by that fraction. So I'm going to multiply both sides by that fraction, and then our answer is on the left. So how can I simplify this? So root 2 times root 2 is 2, and 2 times 2 is 4. Wait a second, I see a 4 in the denominator. So that leaves me just with negative 1 over 3. Done. Do you want me to do it again? Root 2 times root 2 is 2. What's 2 times 2? 4. What do you see in the bottom? 4. So what did I do? And what I'm left with is negative 1 over 3. Number 3. So we're using identities to make it easier to find a trig value. So what am I given here? Cosecant and cotangent. And what am I asked to find? Secant. What identity could help me here? So, do you know that cosecant is the reciprocal of what? Sine. And that what you're looking at is called beta. Just to make sure that we're sure about the symbol that we're using. That's a Greek letter. And sine would be 3 over 7. Cotangent, I'm going to write as tangent. In fact, I don't even need to do that, do I? Let me just do this. Is there a way to connect cotangent and sine together? So what do we know about cotangent? There's more than one right way to get the answer with identities. But what do we know about cotangent above? Is that it's equal to cosine over sine. And once I know cosine, can I find secant? So that's going to help me find the values I need. Cotangent is negative 2 root 10 over 3. Cosine beta, I'm looking for. Sine beta, we just said, is 3 over 7. So I'm going to find cosine, and then when I have cosine, I'm going to do the reciprocal, and then I have what I'm looking for. So how do I get cosine beta by itself? What do? Is I multiply. So I'm going to multiply, not the reciprocal, just the fraction. So can you multiply? So I'm going to multiply by 3 over 7. If 3 over 7 was in the numerator, then it would be the reciprocal. But because it's in the denominator, it stays the same. Then, do you see a way to simplify this? What happens to the 3's? And then what am I left with? Now, how does this help me find what I'm looking for? I'm not looking for cosine. What am I looking for? So what's secant then? The reciprocal. When you do the reciprocal, the sign stays the same. So if it's positive, it stays positive. If it's negative, it stays negative. So it's negative 7 over 2 root 10. And then I'm going to multiply top and bottom by root 10. So I get 7 root 10. And then, do you know how to do the denominator? Root 10 times root 10 is 10. And 10 times 2 is 20. And you have your answer. So secant was negative 7 root 10 over 20 using identities. Turn the page. Correct. So I could have used a different identity and get the same answer. Will some identities be shorter to get the answer and some will be longer, right? And the good news about it is that there's not a wrong way. So what path you take is a good path if you get the answer. Turn the page. So here at the top, do you see the 3 Pythagorean identities? You need to have those memorized. So cosine plus sine equals 1. If you forget the next 2, you could divide by cosine or divide by sine and come up with the other 3 if you don't have them memorized. So cosine theta and tangent theta. I want to find both if sine theta equals negative 1/3 and cotangent's less than 0. So I want to find cosine and I'm given sine. So I'm going to use the first Pythagorean identity. So cosine squared plus sine squared. Well, we know sine is negative 1/3. So square it is equal to 1. Now I'm going to solve for cosine. So I use the first Pythagorean identity, plug in negative 1/3 for sine, and now I'm going to solve for cosine first. So when I solve for cosine, what is negative 1/3 squared? Do you know what negative squared is going to be positive, right? What's negative 1? What's 3 squared? Can you come up with 1/9? For some of you, this is going to be challenging. How do you get cosine squared by itself? You subtract. No calculator here, just you. What's 1 take away 1/9? Think about it. So, some of you recognize when you subtract fractions, the denominator needs to be the same. So instead of 1, it's 9 over 9. And 9 take away 1 is 8. Now, that's not the answer yet. It's cosine squared. So how do I undo that? I square root it. Now, when I square root it, the square root of 8 is 2 root 2. The square root of 9 is 3, but the answer could be positive or negative. Now we got to look here on the top. Can you write down all students take calculus? We need to know what quadrant we're in. What do we know? We know sine is what? Positive or negative? If sine is negative, cross out the bad quadrants. It can't be quadrant number 1, and it can't be quadrant number 2. Correct? Then what else do we know? Cotangent is what? Negative. Which one of the ones that remain, which one is cotangent negative in? Good. So what quadrant are we in? Quadrant number 4. What's cosine in quadrant number 4? Positive or negative? So the answer is positive, right? C, positive. Positive 2 root 2 over 3. Now what else do I need to find? tangent. Now, there are different ways to find this, but do I already know sine and cosine? Then the easiest way to do this is to know that tangent is what over what? Sine over cosine. So sine, we just said, was negative 1/3. Cosine is 2 root 2 over 3. What do you notice about the 3's? What's going to happen? So I have negative 1 over 2 root 2. Then, how do you rationalize it? Multiply by root 2, top and bottom. And then what's the answer for tangent? So negative 1 times root 2. And then root 2 times root 2 times 2. That's 4.
Where did you get root 2 from?
This right here, 2 root 2.
Oh, okay.
Good question, right? Who said, why is it in quadrant 4? And then when I did this work, you didn't want to listen to me. Right? Do you want me to go over again the quadrant? Whoever asked that question on the video? Yeah. So, did you not listen to me? I'm going to go through it again. We write down all students take calculus, yes? What do we know about sine? Is it positive or negative? So, what two quadrants do we cross out because they're positive? 1 and 2. Can't be 1 or 2, can it? Then what else do I know? Cotangent is positive or negative? Negative. So if what's left, which one must it be? Here, cotangent is positive. So the only quadrant that matches is quadrant number 4. Did you get it the second time? Did you get it the second time? Yay, yay. Okay. Number 5. Number 5. Here we go. This will be our last question we're doing for the lesson. We're not going to do the other identities below it. So we're going to end with the Pythagorean identities. Here we go. Tangent and sine. And what are you given? Secant. So, if I want to know tangent and I know secant, which identity will I use? So I'm going to write down tangent squared plus 1 is equal to secant squared. Well, secant is 6 over 5, and then I square it. I want you to solve for tangent. I want to know tangent. You know secant. Which identity uses both? Use it, and then solve for tangent. See? I want to know what tangent is. You're given what secant is. What identity uses both? Use it, write it down, but what secant, you plug in the actual number. Now, you try to get tangent by itself. So write it down. Now, you're thinking, what do I do after I write it down? How do I square that fraction? Well, what's 6 squared? 36. What's 5 squared? 25. Write it down. 36 over 25. Then what do? Subtract 1. Keep going. Do you need common denominators? Yes. So you wrote down 36 over 25. Then what are you going to do to get tangent by itself is you subtract 1. What's a better way to write 1? So you have common denominators. 25 over 25. Just subtract the numerators. 36 take away 25 is, so it's 11 over 25. Then what would you do to get tangent by itself? Is you would take the square root. Now the answer could be positive or, square root of 11 over 5. Alright, so the answer could be positive or negative. So those, are we listening about the quadrant? You ready? Yeah. Here we go. So if I want to know the quadrant, let's start together. Beautiful. Now, what do we know? Secant is positive or negative?
No, positive.
It's positive. Now, secant and cosine, they go together. So that means it cannot be quadrant 2 and it cannot be quadrant 3 because the secant is negative in those quadrants. Have you ever played the game Clue, you know, with Colonel Mustard? And you have to cross out what it can't be and then you're left with, you know, what it could be? Yeah, right? Yeah, we should, right? He did it in the conservatory with a wrench. Here we go. Then, what else do we know? Which means positive or negative? So where, of what's left, which quadrant is signed positive in? So it has to be in quadrant number, which means my answer is positive. Root 11 over 5. Now, what do I still need to solve for? So think, which identity can help me solve for sine? And then I'll do it. Do you think, how will I solve for sine using the identities we talked about? Which one will help us? And there's more than one right answer. What, did I do something? Okay. I know. I like this group. They're very unique. All three of these. Hey, do you know in my brain I can think of 2 ways to get this answer? What's one way to get the answer? Which identity could you use? One way. Tangent, what, keep going, equals? Over? Excellent. Do you know a second way you could do it? That's a good way, and you get the answer. What's the second way you could do it? Anyone know a second way other than tangent is equal to sine over cosine? There's a second way. What's the Pythagorean one? Sine squared plus cosine squared equals. So, do you know cosine if you know secant?
Yes.
So, could you use cosine squared plus sine squared equals 1? Because cosine is 5 over 6. Both are great. You pick one. Go. I'll pick one. I won't tell you which one I'm picking. You pick one. I'll pick one. Do we get the same answer? Both are beautiful. Both are right. Use one. And then tell me what tangent is. Or tell me what sine is.
Oh, I got it!
Yes.
What is it called?
You weren't listening? Like we did the whole all-Tuesday calculus, right? First thing we know is that secant is positive. So then cross out the quadrants, or secant's negative. So I cross out 2 and 3. Yeah? Then I also know that sine is positive. So what's left, what quadrant must be in? So it's what they call a process of elimination. And then you're left with the quadrant. And you are doing like way better. I don't want to jinx it. Maybe it's the late start. I don't know. Here. All right. So, I'm going to use, which identity do you think I'm using right now? Oh, and it's X in this case, so I gotta use X. So I'm going to use the Pythagorean one. So, and let's see if we get the same answer if you use the other one. So I get 25 over 36. Then I'm going to subtract, and then instead of 1, I'm going to write it as 36 over 36. And then with common denominators, I get 11 over 36. Then the last step is to take the square root. So if I square root this, I know the answer is positive. So what is sine x equal? Did you get the square root of 11 over 6? And you would get that answer using either direction. So that's your lesson for today. Can you use trig identities to find trig values? So I want you to turn to the last page to do your homework, and there'll be a quiz on this tomorrow. Mr. G Math, over and out.